Dear students, I am Heena Gupta from Arya College of Engineering and IT Electronics Department. Today, we are going to discuss the next topic of the signal generation and signal analysis unit. In the last lecture, we have discussed about the wave analyzer. Basically, wave analyzer is used for the analysis of electrical signal, and the analysis of electrical signal is used in many applications. As we have earlier discussed that a complex waveform is made up of fundamental and its harmonics, and sometimes it is required to measure the amplitude of each harmonic or fundamental individually. So there is a need of an instrument. So the instrument that is designed to measure the relative amplitudes of single frequency component in complex waveform is known as wave analyzer. Wave analyzer is also known as frequency selective voltmeter or carrier frequency voltmeter or selective level voltmeter. And the basic principle on which wave analyzer work is that it is tuned to the frequency of that component which we require to measure. Actually, the wave analyzers are divided into two categories. This divide is they are divided on the basis of their frequency range. First one is the frequency selective wave analyzer, that is for the audio frequency range, and second one is the heterodyne wave analyzer, that is for the radio frequency range. Actually, the ordinary wave analyzer is useful only for the measurement in audio frequency range but not for radio frequency range and above ranges. To measure the frequency in the megahertz range, special type of wave analyzers operating on the principle of heterodyning are needed. Such wave analyzers are called the heterodyne wave analyzer. Now how it works means heterodyne wave analyzer. What is the principle of the heterodyning wave analyzer? Actually, it works on the principle of heterodyning or mixing. The input signal to be analyzed is heterodyne or mixed to a higher intermediate frequency by an internal local oscillator. And the signal frequency component shift into the passband of the IF amplifier because of the tuning of the local oscillator. And the output of IF amplifier is rectified and applied to the metering circuit. Now we can see the block diagram of heterodyne wave analyzer. This is the block diagram of heterodyne wave analyzer, that how this wave analyzer actually works. In the block diagram, we can see the different type of blocks. First, one is the input attenuator, then untuned amplifier, first mixer, IF amplifier, second mixer, crystal oscillator, there is a local oscillator, there is an active filter section, and there is a meter amplifier and detector section. These are the different blocks of the heterodyne wave analyzer. Now we discuss that how these blocks or how this wave analyzer works. In this wave analyzer, the RF signal which is to be analyzed is applied to the input attenuator. If the signal amplitude is too large, then it can be attenuated by input attenuator. Then untuned amplifier amplifies the RF signal whenever necessary and it is applied to first mixer. The frequency range of RF signal and output of local oscillator are 0 to 18 MHz and 30 to 40 MHz respectively. So first mixer produces an output which has frequency of 30 MHz. Actually, this is the difference of frequency of the two signals that are applied to it. Now there is a IF amplifier. IF amplifier actually amplifies the intermediate frequency signal, that is the output of first mixer. The amplified IF signal is applied to second mixer and the frequency of amplified IF signal and output of crystal oscillator are same and equal to 30 MHz. So the second mixer produces an output which has frequency of 0 Hz. This is the difference of the frequency of the two signals that are applied to it. Now, the cutoff frequency of active low pass filter is chosen as 1500 Hz. This filter allows the output signal of second filter, or this information is passed to the meter amplifier. Now, At last, there is a meter circuit which display the reading of RF signal. We can choose the meter reading in volt range or decibel range. The output of meter detector may also be applied to a secondary device such as recorder, etc. So in this way, we can choose a particular wave analyzer based on the frequency of the signal that is to be analyzed. Means accordingly, if we want the audio frequency range, then we will select the frequency selective wave analyzer, and if we want the radio frequency range, then we select the Hetrodyne wave analyzer. So this is about the different types of wave analyzer. Now we come to the applications of wave analyzer, that what are the areas in which wave analyzer work. First one, it is used to measure the harmonic distortion of an amplifier. Each individual component of a periodic signal can be determined. Secondly, it can be used to separate and display about the harmonics. Third one, it can measure relative amplitudes of signal frequency components in a complex waveform. It can also measure the signal energy with well-defined bandwidth. Another application of the wave analyzer are that it applied industrially in the field of reduction of sound and vibrations generated by rotating electrical machines and apparatus. Also, it can measure the amplitude in the presence of noise and other interfering signals. Another application of wave analyzer that it can be used in harmonic analysis. So these are the applications of wave analyzer.